Welcome back to math. This is section 13, the practice problems for probabilities, combinations, and permutations. Problem 1 says, what is the probability of rolling a six-sided die and getting a 4? Alright, so the formula is the number of possible successful outcomes over the number of total possible outcomes. So on a six-sided die, that means there are six sides, so six possible outcomes. And we only have one possible success here, that's rolling a 4, 1 out of the 6. So it's 1 out of 6, or we can convert that to a percent and say that it's a 16.7% chance of rolling a 4. Problem number 2. If Joe pulls one sock out of a drawer that has 10 blue socks and 6 black socks, what is the probability that he will get a blue sock? Okay, just one event, pulling one sock out of the drawer. So again, our formula is number of success out of the number of total possibilities. So there's just, let's see, we're looking for blue socks, and there are 10 blue socks. So that's a total of 10 possible successes. Out of the total number of socks, that's 6 plus 10, 16. So 10/16, or converted to a percentage, 62.5%. Problem number 3. Now Joe's sock drawer still contains 10 blue socks and 6 black socks, but he's going to pull 2 socks out one at a time without replacing them, so these are dependent events. What is the probability that he will get a pair of blue socks? Right, the first event needs to be pulling out a blue sock. So, success over total. And so success is blue. There are 10 blue, and there's a total of 16. That's event number 1. Event number 2, success now is only 9 possibles because we've already taken one of the blue socks out, and there's only 15 socks in the drawer this time. So now, to get both of them together, we have to multiply 10/16 by 9/15, and that equals 90 over 240. We can simplify that fraction to 3/8. It's also 37.5%. One of the important things about this problem is that they were dependent events because we did not replace the socks. That changed the number of socks in the drawer from 16 to 15 and the possible success from 10 to 9. Remember, we have to assume that the first sock that got pulled out was blue, or we would have stopped pulling socks out of the drawer. Problem 4. What is the probability of rolling a six-sided die twice and getting a 4 and a 3? Alright, so again, success over total. It's a compound event, but they are independent because no matter what you get the first time you roll the dice, it's not going to change the second roll. So the first one is going to be the probability of getting a 4. That's 1 out of 6 total possibilities. And the second one is the same. 3 is 1 out of 6. We have to multiply those together to get the probability of getting both things happening. We get 1 out of 36, and as a percent, that's only 2.8%. Problem number 5. A bag of marbles contains 8 green, 6 red, and 5 yellow. We're going to draw one marble out, replace it, that means independent, then draw another. What is the probability that you will get a red or a green on either try? Okay, so on our first try, let's do the red. Success is 6 red, and the total number in the bag is 19. This is an OR, so we're going to add. It's independent, and we've replaced it. So there are still 19 marbles in the bag on the second time around. And we're looking for green this time as a success. So 6/19 plus 8/19 is 14/19. And that equals 73.7%. Here's problem 6. It says, in a bag of marbles, there are 5 blue marbles, 10 red marbles, 3 yellow, and 6 marbles that are a combination of blue and yellow. If you draw one marble out, replace it, and then draw another marble out, what is the probability that A, the first marble contains blue? Let's start with that. The first marble contains blue. So remember, it's success over the total possibilities. Total was blue, so that's 5, plus we have to include these 6. So that would be 11 out of the total. That's 5, 10, 15, 18, 24. That's number 1. B, the second marble contains yellow. Okay, the second marble, we've replaced it, so these are not even dependent events. These are independent events, and really the first marble is essentially the same as the second marble. But we're looking for yellow, so that would be these 3 plus these 6. That's 9 possible successes out of the bag of 24. And C, what if the first or second marble contains blue or yellow? Well, this is blue and this is yellow. And you'd think that you could add them together. Blue or yellow we add together, but you have to remember that there's overlap. So we have to adjust for the overlap, which is the ones that are blue and yellow. And that is, let's see, it's these 6 out of 24. So to add them together would be 11/24 plus 9/24 minus the 6/24, and that would give us 14/24. As a percentage, that works out to be 58.3%. In problem 7, it says Sally has 5 pairs of pants, 7 shirts, and 2 pairs of shoes. How many different outfits can she wear? Well, we have 5 options for pants times the 7 options for shirts times the 2 options for shoes. We multiply all those together and we will get 70. A lottery game randomly selects 3 balls with the numbers 0 through 9 from 3 full sets of balls. How many combinations are possible? And what is the probability that you will win if you buy one ticket? Alright, so the first ball up, as they say, has 10 possibilities. 0 through 9 is 10. And the second ball, also 10. And the third, also 10. Multiply these all together, and there are 1,000 possibilities. So the probability that you will win if you buy one ticket, so the success of your one ticket over the total equals your 1 out of 1,000. As a percent, that's 0.1%. Problem 9. A salad bar has 15 different items, but you can only choose 4. How many ways can you make your salad? Well, this is a combination because the order in which you select your toppings doesn't matter. So the formula that we're going to use is the one for combinations, and this is where n is the total number of choices, that's 15, and k is how many you're going to select, that's 4. So replacing that in the formula, we get 15 factorial over 4 factorial times 15 minus 4 factorial. Alright, so this is 15 times 14 times 13 times 12 times 11 factorial, and then I'm going to stop there for a reason, 4 factorial is 4 times 3 times 2 times 1. And then, of course, 15 minus 4 is 11 factorial. So that's why I stopped there, is so that we could factor out 11 factorial. When you do all this math out, on the top we get 32,760 divided by 24. And when you do that, you will get 1,365. Problem 10. Bob has 3 trophies for running. How many ways can he order them on his shelf to display them? Okay, this is a permutation because order does matter, and he's going to use them all. He's going to display all 3 trophies. So we use this formula. N is the number of trophies that he's got. So that's 3 factorial, which is 3 times 2 times 1, which is, of course, 6. Problem 11. Bob, the same guy in our last question, gets 1 more trophy, and now he has 4 trophies. Now how many ways can he order them on his shelf? Well, it's going to be the same formula, but now n is 4. So that's 4 times 3 times 2 times 1, which in fact is 24. Problem 12. There are 25 students in dance class, and the instructor will randomly select 4 dancers to go first, second, third, and fourth in the recital. How many different ways could they be selected? All right, so this is a permutation because we do care about the order in which they're selected. And we're only choosing 4 of the dancers, so we will use this formula. N is the total number that we can choose from, that's 25. And R is the number that we're going to choose, that's the 4 that are going to go. Okay, you know this by now. 21 factorial and 24 factorial factor out, and we are left with 25 times 24 times 23. Whoops, that should also say times 22, my bad. And we get 303,600 different ways to select them.